Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show, bringing you another really fascinating guest today, helping to create a better tomorrow on some really unique fronts. We have the honor today of being joined by Commander Dr. Joseph Dituri, who is a retired Navy diving saturation officer who, after 28 years of service to the United States, went back to school to earn his PhD in biomedical engineering at the University of South Florida, ultimately with the goal of performing research in many fields, one in the field of hyperbaric medicine to help address not just diving-related maladies, but also to look for treatments for things like traumatic brain injury, CTE, as well as a variety of symptoms related to things like post-traumatic stress disorder, depression, long-term mental and physical impairments. Dr. Dituri is the author of numerous diver training manuals, co-author of the book, The Tao of Survival Underwater. He's a contributing author, Hyperbaric Medical Practice, and the Navy Diving Manual, and he has been published extensively in numerous journals, including those by the American Society of Naval Engineers and the American Institute of Aeronautics and Astronautics. He also has a new novel out, available on Amazon, called Secrets in the Depth. As a director of the International Board of Undersea Medicine, and in partnership with the Marine Resources Development Foundation Marine Lab, Dr. Dituri just embarked upon this fascinating 100-day adventure where he is now in the Jules Undersea Lodge in Key Largo, Florida, called the Neptune 100-Day Undersea Mission, where he's undertaking medical research, ocean conservation research, various technical developments, and looking to break the current 75-day record of living underwater. Anyway, we're honored to have him with us today. A lot of really cool topics to get into. Commander Dr. Joe Dituri, thank you so much for taking time to come on the show, and obviously thank you for a long history of service to the United States.
You're very welcome. Thank you for having me. I appreciate it. I appreciate the Philly tie-in, that's for sure.
Absolutely.
Hey, listen, Dr. Commander, that's just not going to work. You can call me Joe. Please call me Joe. Mom calls me Joe. Let's just go with that.
I'll call you Joe. Joe, it's fascinating. You've been on this amazing journey. Obviously you started in the U.S. Navy back in the 80s, and along the way, while you were getting your degrees in computer science, and astronautical engineering, you entered this really unique special operations community. I guess Hollywood exposes us a lot to Navy SEALs. We hear a lot less about sort of these deep saturation divers. Take us a little into that world, a little of your background in this space. I know you described it in the past that you're not scuba diving. You're walking along the very bottom of the ocean. So talk a little bit about that.
Yeah. So Spec Ops guys are they've broken down into three categories: explosive ordnance disposal, explosive ordnance management, and diving. So you specialize in any one of those areas, but you do all three. So I've done a little bit of the first two, not enough that I can shake a stick at it, and I still have all my fingers, so definitely didn't do it poorly. But the last area, I became the guy in charge at Deep Submergence Unit, and then from that point, went on to design and build dry combat submersible. Realistically, I'm little more than an engineer that works in the water. So, like I said, I've had a good time. That saturation diving. When we say saturation diving, that means going down and staying underwater for long periods of time. So when I say long, I mean 30, 34, some odd days, you know. So you do that kind of time underwater, 24 hours a day, 7 days a week. You do that kind of time, you get to see things that people generally don't see, right? You get to experience things that people don't experience. So pretty good, pretty reasonable job, if you will. And then when I came up, I decided that we needed to stay longer. You know, I said not only do we need to do the biomedical engineering and the research and all that other stuff behind it, but we just need to stay in the water longer.
And you know, along those lines, you know, I had an opportunity, and I didn't read the whole thing, but I read some of it. So your PhD, which you marked bottom, is entitled "Heart Rate Variability Analysis as a Means of Real-Time Hypercapnia Detection," defined as elevation of arterial carbon dioxide tension, evaluation of patients' dyspnea or altered sensorium. Talk about your PhD a bit, if you would, because obviously you're in and we've talked about this principle in the show, of austere environments, whether it's space or the middle of the desert or where you are right now. Talk about your PhD a bit, and sort of, obviously you wanted to explore further what was happening to you when you were down there, but talk a little bit about that, if you would.
100%. Well, first of all, I have some great news to announce that yesterday I got an email from the U.S. Patent Office saying, all right, you finally answered all of our questions and we're going to issue you a patent. So all we got to do is put together the paperwork to pay for it and all that other stuff. But that's a foregone conclusion. But I will be a patent holder for the U.S. That'll be epic, and Excellent. It is in that particular modality, right? So what we did is, if you take the human heartbeat and you look at it, there's a Q, there's an R, and there's an S, right? If you match the R and then you match the next R, the time between them is about a second, give or take. Realistically, it goes from 0.5 milliseconds or 0.5 seconds to 1.5 seconds. So it has some variability in there. Turns out that if you plot it on a Poincaré plot, and then you use check the standard deviation of the short axis and the standard deviation of the long axis, they're in about a 4-to-1 ratio in the most fit people, right? The more fit you are, the higher your ratio is, right? So you have this ellipse. So what I designed is this ellipse fitting algorithm that goes over that, plus a sensing technology that senses when the ellipse is becoming less elliptical, right? So when it's becoming more circular and less elliptical, that shows and demonstrates through scientific scientific principles and experimentation that your autonomic nervous system is being stressed prior to you having any symptoms. That's the key, right? So here I was in the Navy and somebody died with carbon dioxide poisoning. And I said, last time that's going to happen on my watch. And then when I retired, I went back to school and I said, I think I have a fix for this. And we started working with some stuff. I exposed people to 4%, 5%, 6% carbon dioxide, had them breathe for periods of time, measured respiration, tidal volume, forced expiratory volume, all that stuff. And then finally came down to the fact that I could not only predict prior to them having symptoms, I could early warn them and have them have the ability to shut off. So then we incorporated into my device a little vibrating alarm like the one you have in your cell phone. So it goes, bzz, 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 and there's no way you can ignore that, right? Like, geez, you got the cell phone on your hip, you can't ignore it. You certainly can't ignore it if it's buzzing in your heart. So that's the kind of stuff that we do. And we're just kind of solving the complex problems and tackling it. It also turns out, and I believe, and I wrote this in the dissertation, I believe that it's useful to hyperoxic stress, hypoxic stress, hypercapnic stress, which we definitely proved, and I believe it's decompressive stress. So this is going to be something that long-term, we're going to be able to analyze your body and analyze my body when we go on a dive. When you come back from that dive, it's going to tell you where you need to be at, you personally, for your decompression, given the fitness of your body, given the ability for your blood to transfuse, flow, blah, blah, blah. You know, it's going to be cool. This is the future. So this is monitoring astronauts while they are on EVAs. There's no way to do. I mean, you can stick probes up their butt, but they don't like that. This is a non-intrusive way of monitoring and measuring people without.
Excellent. No, that's really cool. And it gets me, it segues into the next talking point, because obviously, you've spent a lot of time, aside from thinking about these austere environments, in the area of thinking about hyperbaric medicine. And, so here I'm sitting here in Philly, and I'm breathing 20 some odd percent oxygen. I'm not sure what percent you're breathing right now, but we have these hyperbaric dynamics with very high levels of oxygen in the air, and you've been studying things like traumatic brain injury, CTE. Talk a little bit about sort of where we are in 2023 in regard to our understanding of hyperbaric medicine for some of these neurologic conditions, but other things that potentially may be useful.
So I teach hyperbaric medicine at med school at University of South Florida, and I can tell you this. We know the mechanism of action of hyperbaric medicine. It's a known quantity. There are about 7 or 8 things that it absolutely no kidding does. The problem is there's no drug lobby pushing this, right? So there's no billions of dollars to do research to get blinded, peer-reviewed, placebo-controlled papers, which has become the standard, and the drug industry made that the standard, right? So there's a scientific level. And then it's like, oh, well, hold on. You got to go before a phase 2D trial with 420,000 people before we're going to say, yes, it's good. All right. So, perfect is the enemy of good enough. This is not a barbiturate. It is not a narcotic. This is not something you can get addicted to. There are very, very, very limited side effects, and the possibilities are slim and none, and slim just left. You're better off buying a lottery ticket and thinking you're going to win it than having a problem with a hyperbaric medicine treatment. So that's the first thing. But yeah, there are many, many maladies that can be cured right now that we know. I'll give you a perfect, for instance. I'm on a date. And I have this lovely woman, and the server comes out, and she goes, I have a nice pan-seared. And then she looks down at me and she goes, oh my God, it's you. Oh my God, you saved my life. Oh my God. Oh, I wish I had my camera. I want to take your picture. And the girl that I'm on the date with is looking at me like I got 10 heads. Like, who the hell are you? And who the hell is this 20-year-old who's saying you saved her life? Turns out she was one of the young girls that had Crohn's ulcerative colitis, and we did a little experiment on her, right? Because one of the mechanisms of action of hyperbaric medicine, it's an anti-inflammatory. It's a reasonably powerful anti-inflammatory, and it works specifically well in the gut because your gut is very well perfused. We know all this. This is physics. This is physiology, and it's known. Now, what I didn't know is if it would help her. And I was like, look, I'll try and help you out. Her mom was like, well, we're at the point now where she has to go potty every 15 minutes. She is tied to a bathroom. She's on these 2 pills a day, which are horrible for you, called Model. And, they make they make things move slower, I guess, is But the bottom line being, she now has a normal life. She graduated college. Her mother was like ecstatic. She's like, my mom still talks about you at family reunions. I'm like, I didn't do anything. I just said, maybe it'll work. That's literally was my contribution to it. Maybe it'll work, and we'll try it. And then we tried it, and sure enough, it freaking worked. And it's like, so that's an N of 1, right? In scientific data, that's an N of 1. They want me to have 420,000 of those. And I'm like, sorry, not going to happen. Before you can charge insurance. I'm like, I don't even care about insurance. I don't even care about getting paid. I care about fixing the person, right? And I'm not a medical doctor. Like you said, I'm a PhD. So I train medical doctors in hyperbaric medicine, but I can't write a prescription. That's just not my gig. But, I know a little bit about it. I saw this once in a cartoon. I'm pretty sure it'll work.
Excellent. Joe, so here you are. I mean, just literally a couple of days ago, you embarked upon what's called Project Neptune 100. You'll be down there in the the Jules Lodge habitat for 100 days, a world record of 73. Just before we get into sort of some of the things you're going to be doing down there in terms of the experimentation and different sort of research, just tell us a little bit about the place, where you are, and a little bit of, I always, every submarine movie I've ever seen, there's always that little hatch where people come in and, there's no water in it and there's negative pressure and all that bit. But talk a little bit about how you sort of stay dry and healthy and breathe oxygen and all that bit.
Like that hatch?
Okay. There you go.
Yeah. So basically the air is plumbed down from the surface and it's an open bottom habitat. So we plumb air in, it blows the air in, and then it goes out the bottom of the habitat. Pretty straightforward. If you took a glass, turned it upside down and submerged it in the water and kept filling it with air, it would just bubble out the bottom. That's basically exactly what I'm in right now. Now, is it perfect? No, it's 13 feet by 8 feet in diameter, but realistically, there's about 6 feet of usable space in diameter. So realistically, it's about 13 feet or 12 feet by about 6 feet. And I have two of those right next to one another with a common moon pool in the center. The moon pool is basically just a pool, right? Like every good hotel has a pool. Well, this has a pool, no kidding.
Gotta have a pool.
Can't swim in it, can't do anything in it, don't pee in it, it smells, but you get in and out of the water in it. So it's slightly below where we're at. So this entire habitat is based on the pressure of that moon pool at the depth of that moon pool. So we keep pressurizing it to that. So I'm at about 35% oxygen right now.
Okay.
And I am at the bone crushing depth or the banana crushing depth of 22 feet. Did you see the special?
Yeah, I saw the video. That was pretty cool. I just had a banana before thinking about it, but go ahead.
No, it's just fun, right? So here we are. We're not at a deep depth. This is not crazy deep. This is not anywhere near deep as I've ever dove, but it's the kind of thing that we're doing experiments. So while we're down here, I'm doing. We didn't have this stuff when we did Sealab in the 60s, right? So I'm doing EKGs underwater. I'm doing EEGs underwater, electroencephalograms, right? I'm measuring pulmonary function tests underwater. I have a microscope right over here. We're doing microbiology underwater. It's a great thing. I mean, we're doing ear cultures underwater. We're doing ear testing to see whether or not you build up fluid in your ear or get something growing in your ear, and you might have an ear infection. So that kind of stuff is the kind of stuff that we're doing. Plus, by the way, beforehand, I took every psychosocial test and every psychological test known to man, and I'm under the care of a psychologist while I'm down here. Because, look, we're in an isolated, confined, extreme environment, and this is no kidding. I mean, it's a teeny little space, and you get frustrated because you rely upon everybody on the surface to do their job, right? And I'll give you a little, for instance. So, and this is my little pet peeve in the morning, and why I'm just a little short right now. So, there's no caffeinated coffee.
Ooh.
Yeah, like we ran out of caffeinated coffee. I'm like, what the hell?
All right, just go up to the surface then. That's the project's over.
Or to kill somebody. No, but you know what I'm saying? It's like little things like that. Like if I don't look ahead the next day and go, shoot, are there 2 more coffee packets? Because I only have 2 cups of coffee a day. Are there 2 more coffee packets? But for the first 2 days I was down, somebody swam by. The first 2 days I was down here, we did not have any caffeinated coffee, and I didn't realize it. I was just ripping open the pouches and putting the thing in and just doing coffee, right? And so I had a headache. By the end of the second night, I was like, I'm laying in bed and I'm like, I have a huge headache. God, I don't know if I can do this. Good Lord, I don't know what's going on. So I took some Advil, woke up in the morning, and when I ripped open the coffee, I happened to catch that it was green. There was a little green label. I'm like, why is it? Oh, it says decaf. Oh, right. And then they resupplied me with coffee, but now we're out again. It's like, but see, those are the little trials and tribulations of living underwater. Even if you're at the bone crushing depth of 22 feet, it still sucks because you're in an isolated, confined, extreme environment. We're going to Mars, right?
Right.
And Mars is going to take 6 months on the best home and transfer window, 6 months minimum. If we take 6 months and we run out of coffee halfway through, who's going to resupply you? Right? Like these are things that we need to start learning, working through right now to make sure that we are ready to go to Mars. I mean, I'm just being silly, and that's a little silly thing, but there are many, many lessons here that are directly analogous to space flight, space travel.
Yep, absolutely. Most definitely. Along those lines, and because I know that one of the things, and I'll put the link to your website up in the bio of the show. But one of the things that you're very passionate about is sort of this area of biohacking, and you've written about it. We had I don't know if you saw our episode from a couple of months ago. We had Lisa Saunders on. She runs research at SOCOM. Mainly working with the terrestrial special operators on, vitamins and other nutrients potentially to increase resilience in soldiers and so forth. I know you're studying a variety of things, ketone salts and high altitude spacesuits and all sorts of other stuff. Any interesting biohack besides caffeine, which is clearly the most important biohack for me in the morning, but any interesting learnings in terms of the 22 feet, the pressure, relate, in comparison to maybe some of the things that we're learning about biohacking on the terrestrial level?
Yeah, well, we know for sure that here we are at 22 feet, we're at an increased partial pressure of oxygen. So we know that we're increasing the number of stem cells that we have. When I say we know because studies have been done on that. So here we are at a pressure, and at that pressure, when somebody stayed 5 days for 1 hour a day, they doubled the number of stem cells that they had in their body after 5 days of 1 hour a day. So what we're trying to figure out is how many I'm going to have when I'm done here. That's just stem cells. That's just stem cells. Do we talk about, you talk about then from there, the telomeres on the end of the chromosomes.
Right.
Telomeres are the things that help the chromosome duplicate. You can extend the telomere length by between 25 and 33%. That means you can almost add another quarter to your life. So y'all going to live to about 100. I'm going to 125. I'm just saying. No, I mean, seriously, it's yes, that not being said, if you don't get hit by a truck, I understand it's not the end all be all for any kind of longevity thing, but those are just a couple of things. But the one thing that I've stumbled onto lately that is absolutely terrific for those of you that may be experiencing brain fog and kind of post-COVID type symptoms or oxygen depletion symptoms, methylene blue.
Okay.
Methylene blue, it's a food coloring, and it changes ferric ion to ferrous ion, and it you have binding sites on the hemoglobin bus, right?
Okay.
Biconcave shape on the hemoglobin bus. You can only put 4 oxygen molecules on that bus. What it does is it basically it makes them release more easily, right? So it makes it, I'm trying to, it's complex, but there's a switch but it's really complex, but I'm trying to simple it down. So, but when it goes by the brain, those oxygen molecules want to get off. And they want to feed the entire brain. Arguably, your brain uses the most oxygen in your entire body. Truly, it's your eyes, but they're part of your brain. But realistically, you use a lot of oxygen while you're looking around doing what you're doing, thinking. So when people have brain fog, and it's because of post-COVID symptoms, or maybe they have mast cell activation and they're just foggy, stuff like that. Stuff like that can be fixed, can be worked on.
Excellent.
So that's my biohack for the day. There you go.
No, that's great. I love hearing about that.
It's blue food dye.
Right.
Literally, it's blue food dye. Like, we've been eating it for years, right? Like in blue corn chips, you have plenty of that. So don't worry about it. It's not like, is it going to make your tongue blue? Yes. Is it going to make your urine blue? Yes. Is it going to hurt you? I'd say no, because we still make blue food chips, right?
Right. No, I think it's cool in the sense, we touch on sort of this theme of repurposing, as you were talking about the hyperbaric oxygen, about how we have these potential cures for things, maybe not the patents, but they do. I mean, they work, and we need to re-explore them. So I think that's it's another interesting part of the story. Joe, obviously, as we've been talking, you're going to be doing, inside the a lot of research in terms of the resilience, the physiology experiments. So we talked a little bit about biohacking, but outside that window there is, nature's pharmacotherapeutic, or the unexplored pharmacotherapeutic potential of the future, in my opinion. I spent over a decade in sort of the natural products field, looking mainly at terrestrial biomass. And obviously, there's been a very long history of all the cancer drugs and other products that have come from the plants on the surface. But the really smart people tell us, like, look, we've explored none of the ocean. We have a few really awesome cancer drugs that have recently come out of there. You've pointed out on your website, things like the various peptides that may act as antifreeze, and sort of the stickiness of muscle, and what are the other, the glue. We talked about the other. Yeah, exactly. How much
delivery agents? Yeah, yes. I mean, there's all kinds of stuff.
How much bioprospecting can you do when you're down there? And I mean, I see the divers going by, but there's so much just probably off the coast of the United States that we haven't explored. What are you doing in terms of some of that bioprospecting research, if you can talk about that?
Honestly, I'm doing nothing of that actually here, because here we are, we're in a tied-in lagoon. I really don't go anywhere. It's basically, I can swim the size of 2 Olympic pools or 3 Olympic pools, and that's about it, right?
Got it.
And it's a little curtain up, and we shouldn't if we don't get lost. I try not to get lost, but if we don't get lost, we can't get out. And then we're in this one little spot, if you will, but it has to be a protected marine sanctuary area. So one of the microbiologists that come down and visit me, that's one of the parts of this thing, is I get visitors that come down that do their science too, and I get roped into their science, and they get roped into my science, which is really freaking cool, because we're sharing science, right? And then these guys are questioning me, and I'm questioning them. So it's always helping. That's what science does. We question one another and go, I don't believe you did that right? Right. And there's no offense, right? We don't take offense in science. We're grown people, right? So I want my science to be bulletproof, so I want you to try and poke holes in it. That's my thing. So, but what we did do is, we did some biosampling down of the biomat, and pulled some of these amoebas off the bottom of the ocean right here. And we checked them, and we're like, oh yeah, this is very interesting. This looks like it might be something new. So we're playing with that, checking it out, looking at it. So yeah, that's the kind of stuff we're doing there.
Awesome. Really awesome. And Joe, when I was checking out your PhD, I came across, I mentioned in the bio and the intro to the show that you've been involved in many publications, not just your dissertation, but the first one that popped up, I think this goes back to 1994, is a paper you did, International Association of Nitrox and Technical Divers Journal, entitled "Can We Really Breathe Liquid?" And it's really interesting, obviously, dating myself here, but for those of us who remember The Abyss and the liquid breathing technologies in that movie, down the street here in Philly at Temple University, they were studying total liquid breathing technologies for a while in the 1990s for sort of premature infants and lungs and stuff like that. Anything you can talk about on the liquid breathing front? I don't know if this is an area.
Absolutely.
Yeah, cool.
Absolutely. So
cool.
So it's Simon, not Simon Fraser. Simon, oh gosh, I totally spaced his name. But at Temple University, he did the immersion of a premature child, in a fluorocarbon, and basically it's a highly oxygenated fluorocarbon, right? The problem with this liquid breathing, it's great, like it makes sense, the whole thing all makes sense, except for your vision, right? You need to have an airspace in front of your eye to see. So in the movie, they put these little contacts in. Those contacts would need to be adjusted as you got deeper. You got to 1,000 feet, 2,000 feet, 5,000 feet, 10,000, whatever the depth is, right? You would need to have air in there. Otherwise, they'd crush your eye. Here's the problem. When we do mathematical modeling of decompression, the eyes are one of the fastest groups to uptake inert gas. And that's because they use the most oxygen. So they are the most viable. Even when your eyes are closed, you use the most oxygen, right? So you're going to metabolize a lot. So this is something that we still haven't worked out yet, but that should be coming. It's just a long term. But the concept seems right? So the only issue that we have is severe acidosis, right? The natural byproduct of oxygen metabolism is carbon dioxide. Carbon dioxide builds up in your body. You get acidic and changes the pH in your blood, makes everything go wonky. You're not made to breathe liquid. You probably could. You kind of sort of did it when you were young, but not really. You didn't get oxygen from it, that's for sure. But it's kind of one of those. So there's a lot of good things that could come from it, including curing diseases, including helping premature babies. But as for ready for prime time, would I use it and jump in the water right now? I have a few questions. I'm that kind of a guy.
Yeah. I just remember it was Philly local, and I was like, wow, I didn't know that was actually happening. And that's I mean, it's kind of I figure you would know the most about it anyway in terms of it.
It's funny. Back in the day.
Yeah. Joe, coming back to I mentioned sort of early on that you did your master's work in astronautical engineering. You were working on your thesis, orbital determination, life support systems, and all that. And then you mentioned a little bit of the sort of the psychological component of what you're doing and how that translates to, hey, I'm going to be in a spaceship for 6 months headed to Mars. Any other interesting learnings per the aquanaut astronaut connection that are going to be important, 10 years or whenever we head off to Mars, that you can tell us about?
So it's funny. I did the Aquanaut to Astronaut Symposium, and I want to say it was in 2007 or something like that. They flew me in, and they flew all of these really important people, and I'm the diver, right? So like when I say important people, I'm talking Phil Newton, the guy that invented the nude suit, astronauts, these people that Scott Carpenter-like people, guy that was, long story short, I got all these people in the room, and then there's me. And I'm like, hi. So we got together and we talked about this, and we lectured on what was going on with the community, the people, how we do this, how we train people. We train astronauts in the pool. Why? It's the closest thing we can get to zero G. Right? The redistribution of body fluids, it's the closest thing that we can get to space travel. All of this is analogous. And like I said, osteoblast, build bone, osteoclast, break down bone. If you don't bang on your legs and arms and hit them on things and use them, you're going to lose them, right? Because the osteoclasts are going to break them down, right? But, it's the type of thing that we have lots of common problems that we need to work out together, but not the first of which is the redistribution of fluid. You get in the water, the first thing you want to do is urinate because, all your blood is stored in your femoral artery because of gravity. When you're in the water and when you're in space, you don't have that problem. So the same thing in space. You urinate right away when you get up in space, and then, oh boy, now you look like a puffy man. They call them chicken legs because none of the blood's in your legs, right? So same thing in the water. Lots and lots of similarities. So I don't know what I can tell you about about the correlation of those things, but there are just so many things that are just almost the same. And you're in an isolated, confined, extreme environment, same as if you were in space.
Right.
You got to talk to surface or whatever.
I know. I never thought about the fact that I do have to pee a lot every time I get out of the ocean. But yeah, that's interesting. I never thought about that one. But cool. No, definitely. Joe, while I have you, I mentioned you've been involved in a lot of these papers in the peer-reviewed literature. You publish book chapters and so forth on deep sea diving and other technologies. Talk about Secrets of the in Depth, if you would. And you wrote a novel. The main character is named Joe Camisa.
Nice attack from New York. Right?
He's got a brain injury and stuff. I don't know where the character comes from, but He's a deep sea submersion diver. How come you decided to write a novel?
Secrets in Depth. Well, COVID happened, and while COVID happened, this book has literally been sitting in my subconscious and partially on paper for the better part of 17 years, right? 16 years, right? I started writing it as a this happened to me sort of a thing. Like, you know how you keep a journal? I mean,
Sure.
here I am, I'm down underwater, and I'm literally, this is my journal for everything that's happening down here, right? So I'm just
Mhm.
literally writing everything down that happens, just this way I can remember it. From this could be a book at some point, and I don't know, but I changed the names to protect the guilty. Some of it didn't happen, and some of it did. But I can rest assured that I was not swinging off a North Korean trawler in a one atmosphere suit. That did not happen, just for the record. But it is a factional book, and lots of the characters are based on my friends or an amalgamation of what my friends are, if you will. So
Awesome. No, really awesome.
my ex-wife's even in there. That's the cool part.
No, that's really cool. This is just a really fun discussion today, going into all these topics with you. Any before we wrap up, any other messages, maybe specifically for sort of the next generation that may be watching the show? We want to have an inspirational message for the STEM thought leaders, not just of today, but of tomorrow, that are interested in this area, also exploring the natural world as you are, biohacking, whatever the case may be. Take us out, if you would, with a little sort of future-looking message for
Let
them.
me just give you the spiel of what we're doing here first, real quick.
Sure.
But it involves STEM. So I told you about the biomedical engineering that I'm doing on myself: blood, urine, saliva, everything. All that stuff's being done throughout, psychological testing, all of that biomedical engineering stuff. That's all cool, but that's not what appeals to the kids. Here are the two things that appeals to the kids. First, I have visiting scientists come down here. Like right now, I have Dr. Hunter Hines, who's a microbiologist, right? He's down here looking at the biomat. He's pulling stuff up, checking it out. We pricked my finger, pulled blood, and looked at blood under a microscope underwater.
Awesome.
We think that's the first time that's happened. I don't really know that to be the truth, but we're just doing cool science, and we're just answering questions that we have, because we're just kind of thinking that we have that question, right? So I'll give you a short, for instance. While you're underwater, it feels like you have the urge to urinate a lot, like we talked about earlier.
Yep.
Well, how much is a lot? I don't know. Well, let's see. So one of the kids came down. When he came down, it's like, okay, I want you to urinate into this cup and tell us how much you urinate for the entire 24 hours you're down here. And then when you go back up to the surface, I want you to urinate again and tell us how much you urinate for the entire day. So figuring whether or not you urinate more underwater. But I can tell you that it feels more urgent while you're down here, and we feel like we're doing a lot more. So we're just trying to get that science out of the way. But that's the cool kind of science that you can do. And the third thing is we do outreach. Kids come in, they swim in this lagoon. We'll go outside, we'll high five them, we'll take selfies with them as they come down to the window, because that person's going to be involved in this 100-day mission. We do a lot of outreach with Marine Lab up top, and they will send kids down, send people down, talk with people. Like I said, we're going to have Dr. Sylvia Earle come down here. I get to interview Sylvia Earle.
Okay.
I get to hang out on water for a night with Sylvia Earle.
That's awesome.
Whose life is better, right? This is amazing, right? Just so it's not only Dr. Hunter Hines, Dr. Sylvia Earle, Dr. Richard Powell, Dr. Craig O'Connell. I mean, doctor. It's crazy. We're bringing the who's who of the undersea realm down here to talk and then do outreach with these kids so that we can incentivize that little girl who sat right up there, almost could make it. And then finally, by the end, 15 times, I think she tried. She swam down to this window, and I got a picture with her while she was down here. And I was like, you go, girl, right? Yeah. What? Everybody's like, what if you don't make the record? I'm like, what record? We just need that little girl swim down freaking 15 feet and wave at me. Hashtag winning. We're done. I don't care. I could go up right now and be like, yep, we did it.
Well, it's really, really awesome, Joe. I mean, I'm rooting you on, not just for the 100 days, but really with everything you're doing, because it's just such a uncharted area that we continue to really need to explore. And I'm really glad you're leading the efforts there. Again, for everybody that is going to be listening to this particular episode of our show across the various podcast networks or watching on the YouTube channel, again, you've been listening to the amazing Commander Dr. Joseph Dittori. Check out his books, Tao of Survival Underwater, his novel, Secrets in Depth. You can watch him on his social accounts at the Neptune 100-day undersea mission and all the cool things he's doing with bananas and bacteria and other neat stuff. Joe, again, I want to thank you for taking the time out of your schedule. Obviously, thank you for what you do and your long history of service to the United States. And as we say on our show here, thanks for helping to create a better tomorrow on so many fronts via what you do. Really great story.
Oh, thank you. Thank you very much. No, I really appreciate it. And thank you to your listeners for taking the time to hear me out, man. I know I'll do this a lot, lots of talking, but
it was really
it's
great.
fun for me because look, man, passion drives you in the end. It doesn't matter. Money doesn't drive you. Get a job that you're passionate about. You don't work at all. So This is my job.
Awesome message. Another awesome message. All right, Joe, be well.
Be well. Thank you.